All right, welcome to Number Systems Day 2. Again, the objectives today are the same as yesterday. We're classifying and graphing real numbers and then finding the square roots of different numbers and ordering real numbers as well. So again, we're using today just as a chance to solidify our understanding to make sure we understand what we covered yesterday in our lesson online and then our in-class assignment today. So taking a look again at the set of real numbers, that's all we're thinking about today. It's this large set that's composed of two groups. On one side we have rational numbers, and within that set there are several smaller sets that fit within rational numbers. We can kind of think of this as a Venn diagram, but there isn't necessarily overlapping. So on one side we have rational numbers with a whole bunch of other things that fit inside of it. And the other category that we have that make up our real numbers are irrational numbers. Okay, I apologize, that's a little bit sloppy, but we understand what we're talking about. Again, irrational numbers cannot be written as a fraction, and they include items like pi, the square root of 12 would fit over here. Again, all of these are numbers that are not able to be written as fractions. They're decimals that go on and on forever without repeating or terminating. With rational numbers, I'm going to start with the most exclusive group in the middle, and these are our natural numbers. Again, these are counting numbers are often called because we learn to count with them 1, 2, 3, 4. Then we move out to whole numbers, and the only item that's added to this set from natural numbers is the number 0. Then we get to integers, which are kind of the whole numbers and their opposites. So the opposite of 1 would be -1. The opposite of 2 is -2. And then we have a lot of other numbers that fall into rational that don't fit within this category. And they're decimals, 2.4, the square root of, well, I'm not going to use the square root of 16 at this point because it can be fit inside. 8/3, it's something that's written as a fraction. 1/3. I might have 0.6666. Again, continuing on and repeating, we might have something like 0.79. And in that case, the 79 repeats over and over and over. And that pattern will continue. And those are included as rational numbers. So hopefully this visual can help us kind of grasp how we can sort numbers and give us another way of looking at this again. On the following slide here, they're asking us to put a check into every set, every set of numbers that the given numbers over here fall into. So unfortunately, this is supposed to be the square root of 64. I apologize, my secretary must have made an error again. So 5 3/5. We know it's written as a fraction, so we know that it has to be rational. As we look, it could also be, if it's rational, it's also going to be one of these first 3, or it could be, I should say, one of these first 3. In this case, because it's a decimal, 5.6, it doesn't fit into any of these other 3 categories. Okay, the square root of 73 is not a perfect square. And when we have something that's not a perfect square, it has to be irrational. If it's irrational, it won't fall into any other category. Then we're getting down to the square root of 64. If we find the square root of that, we discover that it's 8. Well, 8 is rational. It's also an integer. It's on our number line. It's to the right of 0, so it's a whole number as well as a natural number. So the square root of 64 happens to hit all of the categories. Next we look at 36. And 36 is another one of these cases that also, it's a counting number, and if I find it here, it's going to go all the way over to rational, and it fits into those first four categories. 79 hundredths. Well, I can write that as a fraction, so it can be a rational number, but we wouldn't find it on the number line in the front of our room, so it can't be an integer. If it's not an integer, it can't be whole or it can't be natural. So the only category it fits into is a rational number. Okay, this part's asking us to find the two integers that these square roots are between. So they're not perfect squares, they would end up being irrational numbers, but they help us begin to approximate the value of square root of 14, or the square root of 82, or the square root positive and negative of 118. So to do this, as I'm trying to find which integers it's in between, I want to think about perfect squares that would be above or below 14. So I know this square root of 9 is 3. That would be the square root below 14. Above, I know it's the square root of 16, which is 4. So I know that the square root of 14, if I were putting it on the number line, would have to be somewhere in between those. And so we know that our final answer would be somewhere between 3 and 4. Taking a look at the square root of 82, I know, or hopefully we know, that the square root of 81 is 9. And then as I go up, the next perfect square that we run into happens to be 100, which is 10. So I know the square root of 82 is between 9 and 10, and it would be really close to 9. So if I were to estimate a decimal point, I'd probably go 9.0 something if we were estimating that. Square root of 118, I need to think about the perfect square below and the perfect square above. Below we have 100. Above we would have 121. And in class tomorrow we'll list the perfect squares for, I don't know, we'll go 1 to 20, probably include 25, so that if we don't have them memorized, we can start working on that. So the square root of 100 is 10, the square root of 121 is 11. So we know that this would be in between plus or minus 10, plus or minus 11, just depending on which square we were trying to find. So one's between negative 11 and 10. On the other side, we would look at it as being in between 10 and 11. Again, taking a look and just placing integers and real numbers on a number line. Hopefully this is a review, but I want to make sure that we've got it down quite well by this point in our math career. So I have 0, and I can put a dot there. My apologies, I did not align the board, so my dots are going to be tough to get in place. We have negative 5, which would go here, trying to compensate for where the board is. I have 1, and again, I'm not using a ruler, so these are not as accurate as I would like them to be. Out here we have 3, and then negative 3. Taking a look at graphing inequalities, again, in these examples, I have the variable to the left side. Some of us have noticed that when we do that, the inequality sign tells us which way we should be graphing the answer to this. So in this case, x is larger than or equal to 5.4. We go 0, 5.4. Because it's a greater than or equal to sign, my circle is closed. We know that x is anything larger. So on the right of the number line, we increase, so our arrow needs to go to the right. In our last example here, we have x is less than negative 4. Here I have 0. I can place negative 4 on here. In this case, we just have a less than symbol, so I have an open circle. Again, I apologize. Did not orient before I turned the recording on, so some of my placement is not perfect. But here we're graphing x is less than -4. In this one, we're asked to order each set of numbers from least to greatest. In this first example, I know the square root of 4 is 2. So I need to try and determine what this is. Obviously, 2 times 2 is 4. That doesn't work. 2/10 to the second, that would be 4. And then I need to move the decimal place 2 spots. So in this case, the square root of 4/100 is 2/10. So that's the decimal equivalent. The square root of 1/8 ends up being just 1/8, which is 0.125. So looking at the decimal equivalent there, and then we have 0.17. So the directions are stating smallest to greatest. I can take a look here and find that I should have 0.125. And then I have 0.17 and 0.2. And that's what I would do in my head. My final answer would be using the original problem. So I have the square root of 1/8. And then we have 0 and 1/7 or 17/100. And then the square root of 4/100. That concludes tonight. Again, we'll work on an assignment tomorrow. If you're looking for extra practice and just trying to get comfortable with this, using the 4 lessons in IXL could be helpful. Have a good night. We'll see you tomorrow.